In this video, I will explain you how to find the wavelength associated with a moving electron. Who has told that matter is associated with wavelength or matter is associated with wave? De-Broglie has told, right? So I have to apply De-Broglie hypothesis here. According to De-Broglie hypothesis, the wavelength associated with a matter wave lambda is equal to h by momentum or h by mv. Okay. Now, if I am able to substitute the value of h and m and v of a moving electron, I can get the wavelength associated with a moving electron. But it is difficult to measure the velocity of moving electron. Now I am going to substitute mv in terms of kinetic energy, because kinetic energy is easy to measure. How you know? Let's say we have an emitter and we have a collector. Photons are allowed to incident on the emitter. Now electrons will be ejected out. This electron will move towards the positive plate. So this is how photoelectric current is made, right? Now these electrons are having a kinetic energy of half mv square. That is the reason it is coming from this plate till here. Now if the energy is made to zero, it cannot take the transition from this position to this position. How to make the kinetic energy is equal to zero? By applying a stopping potential. Now this will be negative and this will be positive. On applying a stopping potential in this way, we are giving a negative potential here, and due to this potential, this electron will get a potential energy here and the value will be minus EV0 because it's a negative potential. Now on increasing the value, so let's say half mv square is the kinetic energy. Now I have given a potential. So what will happen? From the kinetic energy, certain amount will be deducted. So on increasing the stopping potential, we will reach a point. So on increasing the potential, we will reach a point in such a way that the potential energy due to the stopping potential, potential energy due to the potential will be able to stop the electron coming out. And that potential is called as stopping potential. Now, till then it is a reverse, a negative potential. Now, this negative potential will try to stop this electron. But this will only happen when the kinetic energy of ejected electron is equal to the potential energy given by the negative potential on that electron. Okay. Now, what is the potential energy given by the negative electron? Which is equal to minus E into V0. Only when this is equal to half mv square, I could say that photoelectric emission is stopped. Now I have given a negative potential. Now this negative potential has given a potential energy to the ejected electron, but this potential energy is not equal to the kinetic energy. What will happen? This kinetic energy will be deducted a bit, but still it will be able to move from here till here. Now only when the potential is raised to a value so that this value E into V0 become equal to the kinetic energy, then only it will be stopped. Now this is easy to measure. I can adjust the value such a way that the photoelectric emission is stopped. So at that position I can say that I can just multiply charge of an electron with the potential I have applied to get value of E into V0, and that will be the kinetic energy at that position or at that moment. Okay, now I can easily, the idea here is it is easy to measure kinetic energy by simply measuring the stopping potential. Multiply the stopping potential with the charge of electron and that will give us the value of kinetic energy. Okay, so that this can be easily, so momentum cannot be measured but kinetic energy can be measured, and we know the relation between kinetic energy and momentum. Half mv square is the kinetic energy. Now multiply this with m, and divide with m. So this will become m square v square divided by 2m. And what is m square v square? mv the whole square. So this is mv the whole square divided by 2m. And what is mv? Momentum. So p square by 2m is equal to kinetic energy. This is a very important relation. So I can say that p is equal to root of 2m ke. Cross multiply and take the square root. Okay, so for mv I am going to substitute momentum, which is root of 2m ke. Now kinetic energy I will simply get from stopping potential, that is E into V0. So H divided by root of 2 into M into E into V0. Now I know all the values except stopping potential because that value will be different with different material. Okay. Now value of H I know 6.626 into 10 power minus 34 divided by 2 root of 2 into M, mass of an electron is 9.1 into 10 power minus 31 into charge of an electron 1.6 into 10 power minus 19 into V0. Now on substituting all the values, we will get the value as 12.27 into 10 power minus 10 divided by root of V0. So root of V0 will be there, everything else can be simplified and that will become 12.27 into 10 power minus 10 divided by root of V0. V0 is the stopping potential and this is wavelength, so this will be measured in meter. So 10 power minus 10 can be written as angstrom meter. So the value will be 12.27 into divided by root of V0, this much angstrom meter. Very important. Okay, 12.27 divided by root V0 angstrom meter. Okay, thank you.